So in this video, we're going to let the player run back and forth, and we're going to do this just using keyboard input. So this shouldn't be too hard. Let's go ahead and just dive right in. All right, so I've got my hero class here, and we already have some stub methods, some stub functions for move left and move right. So one thing that we might be tempted to do is we'll say self, what we want to make our implementation self.rect.x minus equals some number when we're moving to the left, and we'll say self.rect.y or x plus equals some number when we're moving to the right, and then we'll hook that up to input. But this actually isn't going to work well for us because eventually we're going to need to resolve collisions with blocks, and our player could be moving in diagonally, perhaps if it's jumping. So it could be moving in multiple directions at the same time. And so we're going to have to think of another approach. So, and there's another advantage to this approach too, and I'll talk about that at the end of the video. So let me just undo this code. And what I'm going to do instead is add two new attributes to our player or hero class. So the first one is going to be self.speed. This can be whatever number you want. Okay, I'm going to say 5. This is just going to be the number of pixels that the hero can move in either direction, right or left, on any one iteration of the game loop. And I'm going to give another variable called self.vx, and this is going to be the hero's current velocity. And in physics, velocity has a different meaning than speed. Speed is just a positive, like absolute number, but velocity has both a magnitude, like the size of the number, and a direction. And so if our hero has a negative velocity, we'll say it's moving to the left, and a positive velocity would be moving to the right. And so when I move, instead, I am going to, my left function is going to say self.vx equals negative self.speed. And my move right is going to be self.vx equals, and we'll do a positive self.speed. And if you notice right now that neither of these lines have actually updated the coordinates of the hero in any way, right? Those are where it's actually on the screen are bound to the rectangle x and y. And so in the update section, which happens every iteration of the game loop, I'm going to say self.rect.x plus equals self.vx. So now, nothing happens, right? We still can't do anything because we haven't bound it to keyboard input. So we're going to go down here to this line where I'm polling the state of the keyboard, and pressed is going to be a list of all of the state of every single key. And so if we want to check particular keys, I'm just going to say if and pressed, and then in brackets here, I'm going to do the key constant. So I'm going to use the left and right arrows. A Pygame K left, and then we'll say move. Oops. Let's see, it's going to be hero move left, and then we'll say elif, and this will be Pygame.k right, and will be hero.move right. So now let's test this out, and I'll push the right arrow, and nothing happens. And of course, I always forget this. But remember, the actual motion is not getting applied anywhere except for in the update function. So this means in our game logic, we need to say hero.update. And actually, we could also say player.update. And I guess I'm going to be consistent here since, right, so the hero is in the player sprite group. And so I'm going to change this to player.update. I think that's a better idea anyway. If we had a multiplayer game, we might want to just say players.update or whatever we call it. So I think it's good to be consistent between the logic and the drawing code. All right, so now let's see if he moves. Moves to the right, moves to the left. Now, one thing you might notice here is it doesn't stop. And I push right and I let go of the keyboard right now and it doesn't stop. And I push left and I let go of the keyboard, it doesn't stop. And so what that means is, when I was initially designing my hero class, I just thought of, well, what are the three things, that it can do? And I made stubs for them. But it turns out we need another one. F stop. And in this case, we'll just say self.vx is equal to 0. And so now when we run the game, oh, wait. And then when we go down to the keyboard input, we're just going to add a branch else hero.stop. Now let's run this. And so now it's moving to the right. I let go, and he stops, and it can move to the left. Now, I haven't done anything to resolve collisions yet, and I can also go off the edge of the screen and come back on, but we'll save that for another video. All right, so just a couple last little comments here. It's like, well, why did I said that, I'm using this velocity variable rather than just manipulate coordinates directly when I move left and right. And one reason I said that is that it's going to make collision resolution easier. But there's something else that you might want to think about here, and that is, in my move left function, I set the velocity to the negative speed, and in the right, I set it to positive speed, like instantly, right? So the hero goes from 0 to move to full speed as soon as it starts moving. But we now have the ability here, if you wanted to maybe take the velocity and have it decrease by a little bit each time until it reaches some maximum velocity, and you can make it go faster till it reaches some maximum, or so till it reaches some maximum speed. So we could actually, without too much extra work, maybe incorporate acceleration up to top speed rather than just immediately having you run at top speed. The other thing we could do with the self.stop function is maybe instead of having you instantly come to a stop, we could have you slowly come to a speed of 0. So we would just take you down a little bit each time until you reach a velocity of 0. And we could do some fun stuff with that too. Maybe like in a future video, maybe we'll look at adding ice or something, slippery surfaces to the game. So some surfaces you can stop pretty quick, and others you kind of skid on for a little while before you can come to a stop or turn around. All right, so we've got, it does give us a little bit of flexibility here. One more thing with this code that this is maybe just a preference of mine, but I think this line of code and this line of code, are hard to tell apart. And I think negative signs just attached onto variables like this sometimes tend to get lost. They're a little bit invisible and easy to accidentally delete, like, oh, that's a typo or something. So what I like to do is, when I'm negating a variable, is do -1 times that variable. And then I think this stands out a little bit more, and I think it's, it looks intentional. So I think I'm less likely to accidentally just delete that negative at some point and start causing bugs in my game. So, all right, let's just make sure everything still works. Run right, run left. All right, so that's it for this video. If you have any questions, let me know. And otherwise, in the next video, we will deal with some collision resolution.